Section 8.1 is about complex numbers and polar equations. So we start out, and if you have not had algebra or it's been a while, we need to remember some things about negative numbers. The square roots of negative numbers came about in about the 16th century, and they're still used today in science and engineering. What we need to remember for our stuff is I is equal to the square root of -1. And then if you square a radical, you get what's inside. So I squared is -1. Complex number has a real and an imaginary part. A is the real part, BI is the imaginary part. So if you have square root of -16, we never want to leave the negative inside the radical. And so we think of that as square root of 16 times the square root of -1. This is I, so that's 4I. Square root of -48, you can think of it as square root of 16 times square root of 3 times square root of -1. So that's 4, that's I. We're left with 4I square roots of 3. If you are adding and subtracting complex numbers, you want to remember that you're going to add or subtract the real parts, I've highlighted in yellow, and the imaginary parts. So this sum is 11 plus 4I minus 2I is 2I. Now, if you are multiplying, you can do that with FOIL and do it out by hand. So in this case, this 5 times 7 is 35. Outer is minus 15I. Inner is 14I. Last, we have minus 6I squared. And I squared is -1, so -1 times -6 is a positive 6. And then you have 35 plus 6 is 41 minus I. So you could do that if you were dividing by hand and you had 3 plus I over 2 minus 5I. You can't leave the i's in the bottom. So we multiply by the conjugate, which means we're going to multiply by 2 plus 5I over 2 plus 5I. We can do that because that's equal to 1. So when we do that, on the top, if we FOIL that out, we get 6 plus 15I plus 2I plus 5I squared. The I squared just changes this sign, really, because it's -1. So we have 6 plus 17I minus 5. 6 minus 5 is 1, so we have 1 plus, I don't know where that's 17I. I don't know where that came from. Okay, so that's what we have on top. On the bottom, you don't have a middle term anymore because these will cancel the middle terms out. So we have 2 times 2 is 4, minus 5I times plus 5I gives us minus 25I squared. The I squared changes the sign on that, so you have 4 plus 25 is 29. So on the top we have 1 plus 17I over 29. Now, we're going to do them with our calculator. If you want to use your calculator, you just put things in, and we'll see that in the problem set. And to find I, it is the second key and the decimal. So second decimal. So the last thing you might need if you're solving equations with a quadratic formula, the negative under the radical will have complex roots. So you would have some things be real where they cross the x-axis, and some things would be imaginary where they don't have an x-intercept. Okay. The discriminant is this part right here in the quadratic formula that tells you whether you have complex roots, real roots, or repeated real root. So that's some other information. Let's go look at the problem set. Identify the number as real, complex, pure, imaginary, or non-real complex. And this can be confusing because it can be more than one thing. Every number in the world can be classified as complex because you could have a part that was, you could have 6 plus 0i. So that's the deal here. This could be called a complex number if you thought of it as plus 0i. And it's a real number. It doesn't really have the imaginary part. Number 2, 4i is non-real, complex, and pure imaginary. It doesn't have the real part added on to it. 6 plus 3i is non-real complex because it has a part real part and a part imaginary. So complex and non-real complex. Pi is a complex number because it could have a 0i and it's a real number. 5 square root of negative 144 is the same as 12i. And so that's pure imaginary, non-real complex, and complex. Number 6, we start getting into simplifying. So if you have the square root of a negative number and that number is a perfect square, you're just going to take the square root of it and it'll have I. So square root of negative 4 is 2i. Square root of negative 17 is like the square root of 17 times square root of negative 1. This is I, so it becomes I square roots of 17. If you have square root of negative 96, I did that over here. I said, well, that breaks down to negative 16 and 6. Negative 16 is the same as 4i square roots of 6. Negative square root of negative 245. Well, that tells me I'm going to have a negative on the outside anyway. I wrote it here. Now I'm breaking this down. That's the same as the square root of negative 49 times square root of 5. So this negative stays, and we have 7i square roots of 5. Adding and subtracting, remember you do real parts and imaginary parts. So 9 and 6 is 15, 8i minus 7i is I. That's your final answer. Negative 2 minus a negative 7 is 5. 4i minus 4i is 0i. So we actually, negative 2 plus 7 is 5. That's our final answer. Now these I showed in the calculator because you're multiplying. Remember to get the I, it's second and the decimal key. And so when you do it in your calculator, you just put it in just like the problem is written, and you'll get 14 plus 18i. All right, let's go down one more. Same idea here, put it in the calculator just as it's written in the problem. You get 18 minus 39i. And then 14, square root of 8 plus I times square root of 8 minus I. Remember that's going to, we don't have a middle term now, so square root of 8 times square root of 8 is 8, minus I times I is I squared. I squared is negative 1, so you end up minus a negative 1 is plus 1. Final answer is 9. So there's 14, but those should go really quite quickly to get you started.